Welcome to Data Protection Gumbo, Season 2, Episode 9. I am Demetrius Malbro, your host and Chief Data Protection Chef, and I am honored to bring you more gumbo of insights and information about data protection today. And we have Nigel Lambert on the show today. And Nigel's career in IT began in 2007, where he played a key role helping to build one of Cisco's largest distributors, now known as Comstore. He went on to run channels in EMEA for a number of well-known startups such as Riverbed, and more recently has been establishing Bridgeworks in markets across the globe. Bridgeworks is a British tech company with a unique WAN data acceleration technology. And I'm excited to speak with him today, so sit back, relax, and enjoy the show. Welcome to the Gumbo, Nigel. How are you today?
Very well, thank you, Demetrius. Thank you for inviting me into the call.
Okay, awesome. Let's go ahead and jump right into the questions here. All right, so the first question I have for you is it just latency, or are there more issues that impact your ability or our ability to move data efficiently?
Okay, Demetrius, that's a good question. So when we think about the movement of data over the WAN in respect to data protection, both the backup process and more importantly, the recovery process, if latency was the only issue that affected our ability to move our data efficiently, we could use a technique such as parallelization to actually move our data as efficiently as possible over the WAN. But latency is the only challenge, as an only challenge exists in a perfect world. In the real world and in reality, we have a number of issues that affect our ability to move our data, which directly impact our RPO and RTO and our ability to recover. So when we look at networks, we're sold typically a quantity of bandwidth, but we're also sold a service level, and that service level pertains to packet loss. And we're sold a packet loss SLA typically here in Europe about 0.1%. So if we look at latency alone, we can drive efficient data throughput using parallelization. So we could take a WAN link and we could take it up to, let's say, 98% of the capacity of the WAN over any distance. As soon as we inject a small quantity of packet loss into the equation, typically 0.1%, the actual throughput using parallelization alone actually falls through the floor. It falls off a cliff. So not only do we have to think about latency, we have to think about packet loss. And not only do we have to think about packet loss, we also have to think about the way our data is coming onto the wire or onto the WAN and coming off the wire. We call that the ingress and the egress. So if we can overcome the challenges of latency through parallelization, and we can mitigate or avoid the packet loss before it takes place, we can move our data very efficiently. If we're always moving our data at max speed and the target data center assets are tied up with an application, then we can create packet loss in the target data center, which again has a direct impact on the data throughput. And that can actually create what's called the accordion effect. I'm guessing, Demetrius, you've been stuck on the freeway before, and you've come to a standstill, and then you've pulled away, and you're looking for the accident or the crash that created the traffic jam, only to see there's nothing there. And that is an example or an illustration of the accordion effect. So there are a number of factors, a very three-dimensional challenge to moving our data, Demetrius. Yeah.
Okay, great. Yeah, you threw a lot of good information out there. So latency, packet loss, egress, ingress, and accordion effect. That's one that I'm not too familiar with, but I like your explanation there around traffic. So how does the variance of these factors impact your ability to deliver, let's say, consistent high-speed data transfer over time?
Okay. So when we look at the three factors we've just discussed, latency, packet loss, and the ingress and egress of our data, none of them are constant. When it comes to understanding the characteristics of a WAN link and what we need to do to maximize the efficient movement of our data. It's like a constantly moving feast. So when we're talking to end users and we talk about on the subject of latency, and we get a consistent, we have 40 milliseconds of latency, and you kind of get that repeated through a conversation until we have a chat about variance. So recently we were having a conversation with a well-known British retail brand who was running a data center over around 45 miles, a production and DR system with a latency of around 1.6 milliseconds. And when we asked the question again, the feedback came back interesting. It's 1.6 milliseconds for a majority of the time, but at any time it can spike up to 50 milliseconds. Okay. Now, at 1.6 milliseconds and 50 milliseconds, the speed with which we can transfer our data varies considerably. Okay, that's one issue. When we look at packet loss, we're sold an SLA, and that may be 0.1%, for example. But again, packet loss, there's no such thing as 0.1% packet loss. Packet loss is constantly varying, and it may fluctuate between 0.01% to maybe 2 or 3%. So again, has a significant impact on the ability to move our data. When we look at the ingress and the egress of our data, we think about the target data center that we want to move our data to. You know, we don't control applications and who is spinning up what applications and when. So we don't really know when we should be throttling back the data throughput in order to achieve the maximum efficiency in data transfer. So all that leads to a high degree of uncertainty. And if we can manage that variance, so if we can mitigate the impact of latency, if we can avoid the packet loss before it actually takes place, and we can understand how well our data is coming onto the wire and leaving the wire, the ingress and egress, then we can remove that variance. Not only can we, what does that mean? Not only does that enable us to deliver consistent times for our data transfer, meaning a backup, replication job, or indeed more importantly, recovery. It also means that we're not going to get the intermittent failures that a lot of customers experience when they're driving those services over the WAN itself. Does that make sense?
Absolutely. It does make sense. There was a pretty cool catchphrase in there that I think we just discovered the title of the podcast, A Constantly Moving Feast. I think that's a... I don't know why that stood out at me, but I think that's a pretty slick way of putting it, because you said that none are constant, and then it's like a constantly moving feast. And I'm saying, wow, I've never heard that before. But moving on to other use cases for your technology. So is it just remote backup and recovery, or are there others?
The conversations tend to start around backup, more importantly, recovery, replication for data protection. But when a customer begins to understand and gets their hands on our technology, and that's the key to this actually, get their hands on, understand what our technology delivers in terms of value, the conversation soon actually is not just about addressing the backup and recovery needs, but also how we can support and how we can make their production systems more efficient. Whether you're looking at global workflow, say, for example, advertising agencies. You know, you may shoot some film for an advert in one location, let's say Arizona. You may need to move that film into an editing suite in Soho, London, and then you may need to move it again to a language and distribution part of the organization. So we can help speed up workflow production systems as well, whether it's media and entertainment, whether it's life sciences and pharmaceuticals, or indeed engineering. So if people need to move large quantities of data over distance at the maximum efficiency, that's where we come into play, both from a data protection perspective and from a production perspective.
Okay, great. So let's zoom in and kind of pinpoint on backup here. Um, I guess so. Just how can you accelerate backups, especially when they are like deduped and compressed and encrypted deltas? All of that is being moved over the WAN.
Okay.
How can you accelerate backups if that's the case? And I guess there's really
Okay.
nothing else that can be done because you've already kind of implemented all those different types of features and functions from the backup software, right?
Okay, so you're absolutely right. So what we're doing through those processes is we're trying to minimize the burden of the data, to reduce the weight of that data that we're moving over the WAN, to make it appear that we're moving that data faster. Now, we can have the best technology that delivers the best dedupe, the best compression, and the best deltaing, but the payload is the payload. So if we took a data center in Arizona and one in Rhode Island, so we're probably looking at about 86 milliseconds of latency with a degree of packet loss. Even if we can crunch a 0.5 terabyte backup into 50 gig for a daily backup, we've still got to move to 50 gig. Now, if you take that example, that could take you between 12 and 19 hours to move. So if your SLA, your recovery point objective and time objective, lock you into an SLA that's lower or less than 12 or 19 hours, you can't achieve your goal. In that example, with our technology, with no changes to the workflow or the applications, we can drop in our technology and reduce that backup window on the incremental from 12 to 19 hours to around about 45 minutes consistently if we were moving that data over a 600 megabits per second WAN link. It's quite a dramatic change in the time it takes, but probably as importantly, consistency, 45 minutes. So it's a really good example of how we remove the variance in the time it takes us to move that incremental, also accelerating the rate at which we can move that data.
Okay, so what about the cloud? Are you linked into that?
Yeah, so the cloud has very similar problems to we're moving data over the WAN. So how we seed our data into the cloud, how we access the cloud, how we treat the cloud from a data protection perspective, and also from a production systems perspective. If you consider on a 1 gigabit Ethernet link, moving one stream of data across 40 milliseconds of latency, so that's halfway across America, you'll be at about 3.5%, 4% utilization. You'll be using a fraction of the capability of that WAN link. With our technology in the mix, we will actually increase the data throughput to up to 98% of that 1 gigabit per second link. So we can drive data, we can take data from around 3-4 megabytes per second up to around 112 megabytes per second.
Okay, great. So
whatever we're doing, backup, recovery, production systems, we can make it move infinitely faster.
Okay, and who doesn't need faster backups, right?
Exactly.
So are we talking purely TCP/IP based applications?
Okay, that's a good question. So we have two broad ranges of products. I think the interesting discussion here is that we're acting natively, whether we're looking at a protocol level, protocols move and manage blocks of data build into files. So whatever your discussions and wherever the thoughts are of an end user, we can talk to that end user about how we accelerate their data natively at whichever level they want to consider. So we have a product called WAN Rocket, or a product family called WAN Rocket, and it's basically all things storage protocol. So we could, for example, we can accelerate fiber channel, iSCSI, and SAS traffic. So to give you a good example, we can take a server in Sydney, Australia, and we could back it up to a backup as a service facility in Atlanta. And we could do that backup as fast over that distance as if the tape backup system was local to the server in Sydney, Australia. In fact, recently, we ran a snap mirror replication job from North Virginia to the Rockies. That's over 2,000 miles, right? Over a 10 gig link. And the speed with which we completed that snap mirror replication job was only 6 megabytes per second slower than the equivalent LAN side job. So we could do protocol acceleration and optimization at a storage protocol level, fiber channel SCSI SAS. We can also do it at a TCP level, looking at applications such as SnapMirror, Commvault backup, object storage, so S3, HTTPS, etc. Okay.
Okay, great. So I guess kind of two questions in one here. It's because to me this sounds kind of just like, I guess, or maybe WAN optimization. It reminds me of a riverbed type of product, right? And is it hardware or is it software or is it both?
Okay, so let's take the WAN optimization question.
Okay.
So I think we can sum this up in a nutshell. So to us, all data is equal. So we can accelerate encrypted data, encoded data, and already deduplicated and compressed data just as readily as open data.
Okay.
So what I'm saying there is that we're not using deduplication or compression techniques to make it feel like we're moving our data faster by reducing the quantity of data we're moving. What we are doing is actually fixing the transport problem between two locations. Okay? Does that make sense now?
Yes, that makes it more clear for me. Yes.
Okay. The technology itself is deployed in either a hardware format. So we scale up to 40 gigabits per second today. So we can run virtual systems or a virtual appliance up to 10 gigabits per second. Okay, we need no hardware for that.
Okay.
When we start talking about multiple 10 gig links, of course, we're talking about pretty high levels of throughput. So we need to control the underlying hardware assets, and that's when we tend to need the physical devices, and we can mix and match. So a customer can have a combination of virtual, maybe in the data center where they've got their skills, and they can put physical devices at the edge, where they may have skilled people that have skills in other areas outside of IT. Okay,
great. So it sounds like this is, I guess, it sounds complicated and expensive to me. So how simple is it to use, and do you really need to take like an extra training class, or how long does it take to set it up?
Well, as with all products, Demetrius, there is a level of depth to understanding the technology and the detail there. But when it comes to our tech, for example, as an example here, we don't need there's no application level integration, and there are no agents.
Okay.
This technology, after the change control to drop the hardware in or create the virtual machines, to put the software appliances on it, is complete. It's a 15-minute job.
Wow. Okay.
So that just shows you how simple this is. The other question was around cost, right? It sounds expensive.
Yes.
And I have to say to you, if you're used to the WAN optimization space, when you start talking about 10 gigabits per second, you're in the seven figures.
Yes.
So at 10 gig, we're actually at around about £60,000 per location. So we believe that the WAN, the link speed's going one way, and that's ever increasing quantities of bandwidth. And we've priced our technology accordingly to make it affordable.
Okay.
So it's kind of hopefully not one of those too good to be true or cost $1 million situations.
So it'll be well worth the effort for someone to look into it if speed speed of backup, speed of recovery really makes a difference, which I don't see why anyone would turn that down.
You just summed it up there, Demetrius. It's all about the recovery. It's not about the failover. It's about the failback.
Yeah, and most people really, I guess most people don't really understand that, because you have lots of individuals and vendors out there, really raving about their backups, but the recovery is where it's at. That's where the money is, right? So if you can recover that very quickly and efficiently in the process, you will be the hero, definitely.
Absolutely. So let's take that example we had, right? Arizona to Rhode Island, a 600 megabits per second link. Okay. Now, if we were using delta ring and dedupe technology at each end, it would help reduce the payload. Okay, we could take it down to 50 gig. Now that could take a long time to move, and we can accelerate that. If we remove the VTLs or that dedupe and compression technique from each end, however you're doing that, and we start to back up the complete data set rather than the delta, we can do that very quickly.
Okay.
So we can do 0.5 terabyte over that link in about 4.5 hours as a backup. Now, let's just say our facility in Arizona, something's gone wrong, and we've had to move 2,000 staff 2 blocks down the street. We've lost all of that precious data locally. It's gone. Okay. Now, if we needed that dedupe and compression technique to execute the backup, how are we going to complete the recovery? Because if we've got a bunch of apps now running out of Rhode Island, and 2,000 users in Arizona trying to use those apps, guess what? It's not going to be a great situation. You might have failed over, but are those apps really usable by the business? With Bridgeworks, we can move all the data.
Okay.
We can spin up a nice, shiny new data center in Arizona. We can put a new instance of Bridgeworks into that data center, and we can recover the entire data set in around 5 hours.
Wow. Okay. That's impressive.
Okay.
Now,
and we have customers using that in the States today, in the United States.
Yeah, and speaking of that, Bridgeworks is not something that I've heard of it before, because I play in a space and I've been around for almost 20 years, but it's not. I don't see it often. So why haven't I heard of Bridgeworks before, I guess, now? Or why, I guess, speaking for a customer or a potential customer?
Okay. So Bridgeworks has a deep heritage in the storage market. In fact, if you've used or touched a Dell tape library, we've actually used our technology as an example. So we've traditionally sold through the OEMs. A good example with this technology would be IBM. So if you're already using a Storewise, the mid-tier storage systems, the V7000s or 5000s or whatever it might be, with IP replication, our technology is enabling that IP replication already. So IBM has actually been using our tech for in excess of 5 years now. As an example, what we've decided to do is bring Bridgeworks to market as a product and a brand in its own right.
Okay, great. So I think all of my questions have been answered, and I really appreciate you taking the time out to come on the show today. I have a much better understanding of Bridgeworks and WAN optimization and speeding up your backups, and even a much faster recovery and the constantly moving feast. That's my new catchphrase for the weekend, I guess.
Perfect.
So it was awesome having you on the show, and you enjoy the rest of your day.
Demetrius, take care. Have a great weekend, and thank you very much.
Awesome. Thank you.
Thank you so much for listening to Data Protection Gumbo. I appreciate each and every one of you. I would like for you to check out the website, dataprotectiongumbo.com. You can also follow me on Twitter at dmalbro, or you can link up with me on LinkedIn. Thank you so much. Have a great one.